REST API semantic search on vector database project. So this project is centered around the creation of a vector database to manage and search through sports-related data based on the semantic similarity. It leverages Qdrant for vector database management, Cohere for generating text embeddings, and Rust for backend development. So the application is designed to be scalable, reliable, and easily to deploy with Docker and AWS service. And here's a brief demonstration of the functionality of my project. So the process involves data injection into the vector database, semantic search, query execution, and visualization of the search results through our simple REST API, accessible via our public endpoint. So here in this web page, user can enter a search query related to sports, and the system then leverage our vector database to return the top 5 sports that closely match the search items. So here in my example, my query is play a ball, and then you can see that the results return all kinds of sports that relate to playing with balls, such as baseball and soccer. And also we can test another entry, such as, let's say, in the water. So now we can see that the results returns all kinds of sports related to in the water, such as swimming and surfing. And now I'm going to go over the detailed development stages of this project. So the first stage is to initialize the cargo lambda using cargo lambda new and the folder name or repository name. And the second stage is to sign up for Qdrant and Cohere. So I signed up for Qdrant to create a vector database cluster and obtain the API key and cluster URL. I also signed up for Cohere to obtain an API key to generate embeddings for the vector database. And then the third stage is to modify the Rust content. So I store the Qdrant and Cohere API keys in a .env file, and I create a sports JSON file containing keys and for various sports and their descriptions. So here in this sports JSON file, we can see the key for different kind of sports and the descriptions listed. And then we enter our first mini stage about data ingestion. So this stage is mainly about modifying the setup RS under the SRC folder. So the setup RS script is our Rust-based utility designed for initializing and populating a collection within Qdrant and optimized for storing and searching through embeddings. It serves as a comprehensive tool for initializing a Qdrant collection with vector embeddings generated from text descriptions, and it utilizes Cohere's API. And then I added 2 bins in the Kagotomo file. So these 2 bins are temporarily added to run the file separately from main.rs. And as we can see here, these are later commented out for easier deployment debugging. And now, after all this is done, I can export the access key, and I run the bin for data ingestion by running this line. And then I can go to the Qdrant dashboard and check the test collections. So here, let's go to our Qdrant cluster dashboard. And we can see that the Qdrant cluster have a collection filled with associated embeddings, or called points here. And here we can see the general information for this collection. And then after all of this is done, we enter our second mini stage about visualization and aggregation. So this stage is mainly about modifying the main.rs under the SRC folder. So the main.rs script is designed to act as an AWS Lambda function that processes web requests, interface with the Cohere API to generate text embeddings, and uses those embeddings to perform similarity searches in a Qdrant vector database. So essentially, I would say main.rs functions as a serverless service. It leverages AWS Lambda to integrate text embeddings capabilities from Cohere with vector search functionality from Qdrant. So in general, it handles web requests, generates embeddings for text queries, searches for similar items in a Qdrant vector database, and then returns the search results as HTTP responses. And so after we modify this main.rs file, we can use Cargo Lambda Watch to test the whole thing locally. So I test the visualization and aggregation by sending our GET request in the Postman. So here we can see that my query is play a ball, and then it successfully returns all the results related to playing a ball here. So it proves that my test is successful locally. And then we enter our third stage, which is about setting up AWS IAM user for Lambda function. So here I included all the details about how to go to IAM to create a user in AWS, and how to create a Lambda function linked to API gateway without a Docker image as a test. And then after the test about API gateway without a Docker image is successful in this above stage, I can then proceed to create a Docker image. So the Docker to create a Docker image, we need to modify the Docker file. So this file is essentially outlines a multi-stage build process for creating a Docker image suitable for deploying an AWS Lambda function written in a language supported by the Cargo Lambda tool. And it specifically targets the ARM64 architecture. And then after completing all those steps listed here, I built the image in Amazon ECR, and I linked the Lambda function with API gateway with image hosted. So here we can see that in my Amazon ECR, I already have the week 7 image details hosted here. And here you can see that I have several attempts, and this is the latest one. And here we can also see that the API gateway is successfully linked to the week 7 new Lambda function, and it is hosted with the image. And then we enter our last stage, which is about building a CI/CD pipeline for deployment. So in order to do this, I modify my GitLab CI YAML file. And the YAML file is divided into 2 main stages. The first stage is build and test, and the second stage is deploy. So in the build test stage, it sets up the development environment. It installs necessary languages and tools, and performs linting, formatting, testing, and building tasks. And in the deployment stage, it prepares for deployment by building a Docker image, tagging it appropriately, and pushing it to the AWS ECR for deployment. And then after I modify this YAML file, I then attach environment variables to my GitLab, and I push the repository. So here we can see that my pipeline is successfully passed in my GitLab file. And here we can see that the build, test, and deploy stages are successful. And that's basically all about my project. And thank you so much for listening. I will see you next time.